Programming 3.6b. When you own a business, obviously you are trying to maximize your profits while minimizing your costs. And linear programming is a way in which we try to analyze what is going to be the best deal for us in order to do both of those things. So here we have a bakery. They supply two types of bread, whole wheat and rye. Why rye is capitalized, I don't know. One batch of whole wheat uses 5 pounds of oats and 3 pounds of flour. One batch of rye uses 2 pounds of oats and 3 pounds of flour. The company has 180 pounds of oats and 135 pounds of flour available. Question. One batch of whole wheat yields a profit of $40 and one batch of rye yields a profit of $30. Find how many batches of each bread the bakery should make in order to maximize their profits. Write constraints, inequalities, that could represent this situation using W for the number of whole wheat bread batches and R for the number of rye bread batches. I think that's supposed to be an S there. Include the obvious constraints as well. Well, a constraint means a limitation. And as I read this, we have 180 pounds of oats and 135 pounds of flour available. So to me, those are my limitations. I have 180 pounds of oats and 135 pounds of flour. I'm assuming I own Yum's Bakery. And I make two types of bread. I make whole wheat and I make rye bread. Well, it said that one batch of whole wheat uses 5 pounds of oats and 3 pounds of flour, where rye uses 2 pounds of oats and 3 pounds of flour. Now, where it says max or min, this is where I think we're going to talk about our profit. We're trying to maximize our profit. We make $40 per batch of whole wheat, and we make $30 per batch of rye. These numbers aren't really necessary for this table. We will use them later when we write our maximizing, minimizing equation. So, what are some obvious constraints here? Well, I hope it's pretty obvious to you that I can't have a negative amount of batches of whole wheat or of batches of rye. Oh my gosh, I have not done a cursive R in forever. And that's going to lead us into quadrant 1. So if you look down here, the graph they gave us is a quadrant 1 graph. So those are our obvious constraints and giving us that graph to show that. Now, going this way, we have a constraint on our oats. So 5 pounds per batch of whole wheat plus 2 pounds per batch of rye, and my maximum amount I have is 180 pounds, so it's either going to equal 180 pounds, I'm going to use it all, or I'm going to use less than that. And then the other constraint is on the flour, where I use 3 pounds of flour on the whole wheat batch, I use 3 pounds on the rye batch, and I need to keep that under or equal to 135 pounds. Now, graphing our feasible region, once we figure out our constraints, it's going to be way easiest to do this on Desmos. But for right now, I'm going to show you the old-fashioned way. So if I have the equation, if I'm just going to write this 5x plus 2y is equal to 180, if I plug in 0 for x, I get y is 90. And if I plug in 0 for y, 5 goes into that 3 times. That's 15 with 30 left over. So I think that's going to be 36. So I am going to graph this. And my y-axis, I need to get up to 90. So I think if I go by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90. And I'm just going to label that at 90. So it looks like I'm going to have x was representing my whole wheat, and y is representing my rye. So basically that's saying if I don't use any of the oats for the whole wheat batch, that I'm going to use 90 pounds for the rye batch, is basically what that's saying, for 2 batches of rye. And on my x-axis, I need to get to 36. Now, if I go 1, 10, 20, 30, that's going to be a little small. So I'm going to go by 2. So I'm going to go 10, 20, 30, 40. So 36 is just a little past that 35 mark. I'm going to make a very, very high-tech straight edge here. And I am going to connect those x and y intercepts. Now, obviously, using Desmos is going to be a lot faster and more efficient, but it's all right. So 5x plus 2y is equal to 180. Now, I'm going to choose a different color. Oh, while we're thinking about it, we should think about the shading here. This was actually a less than or equal to sign. So if I plug in 0 and 0 for the number of wheat and rye batches, 0 plus 0 is 0. Is 0 less than or equal to 180? That is a definite yes. So I'm just going to put little arrows in, and definitely we would be shading up and to the right for our constraints that whole wheat has to be greater than 0 and rye has to be greater than 0. So that's where we're at right now. Oops, sorry, I wasn't showing that. What a dork. Now the other constraint was 3w plus 3r. I'm just going to change it back to an equal sign and x's and y's. And this one's kind of nice because I have the same numbers. So 0 plugged in for x yields 3 times what equals 135, and I am pretty sure that that's going to be 45. And then if I plug in 0 for y, I'm going to get 45 for x, so that's kind of nice. Let's see, that was 40, so here's 45, 10, 20, 30, 40, 45. And let's make that line, and that looks pretty good. And again, this was less than or equal to, so if I plug in 0, 0, 0 plus 0 is 0, 0 is less than or equal to 135, that shading would also go toward where the origin is. So what I am seeing as my feasible region is this quadrilateral, this 4-sided shape that is, ooh, it's a little tricky right there. So it looks like going to be this quadrilateral right there near the origin. Looking good. So our next step, once we have that, is we need to identify the vertices on this graph. Well, I should be able to do that. Here, I'm going to scrunch my graph down a little bit. Let's zoom out just slightly. And if I look at my feasible region, the region where the answers could occur, there's an obvious feasible point at the origin. Now if you remember, this point right here was at 0.45. This point down here, that was the one that was at 36.0, so see how important your x and y intercepts are, knowing how to find those. And then this point right here is actually looking like it's on the line 30, but I'm not quite sure what this one is. So I went to Desmos and I double checked, and that is actually at 30.15. The way you could really find that is by taking your 2 equations, right, going back to equations, and doing the elimination method. Now, of course, this would be a little more annoying than normal because we don't have anything that eliminates easily, and I would have to, let's say I'm going to try to eliminate the y's. I would maybe multiply the top equation by -3 to make that a -6y, and I'd multiply the bottom equation by 2 to make that a +6y. So long way to find that intersection is using our elimination method, but Desmos, and I'll show you that in a little bit, is a lot faster and a lot easier. Alrighty. It says, write the objective function for this problem. Well, let me go back to what my constraints were, and that objective. Our objective here was to maximize our profit. So we want to maximize our profit for wheat bread and rye bread, and it's going to be $40 per batch. We're going to make a profit of $40 per batch of wheat and a profit of $30 each of the rye bread. Last but not least, how many batches of each bread should we make in order to maximize our profits? Well, the beautiful thing about the feasible region is that the maximum is going to occur at one of these vertices. Now, I'm pretty sure if I don't make any batches of wheat and any batches of rye, I'm not going to make any money at all. So I am so sure that that is not going to be my correct answer. Well, the old-fashioned way to do this, and I'm going to write M instead of max for wheat and rye. I'm just going to copy this down here again. So basically, we want to substitute in each of those W for wheat and R for rye into our equation. So in this case, it's saying if we don't make any wheat bread, but we make 45 batches of our rye, and I work my magic, and I think that's $1,350. If I plug in that I'm not going to make any rye, but I'm going to make 36 batches of wheat, I don't really even need to plug this in because that's just going to cancel out. In that case, I'd make $1,440. And then last but not least, if I make 30 batches of wheat at $40, that's $1,200. And if I make 15 batches of rye at $30 a pop, it looks like I'm going to make $1,650. And that is going to maximize my profit. So 30 batches of whole wheat bread, and 15 batches of rye is the solution. Now I'm going to get on Desmos and show you how much easier that is to do on there, and obviously how much easier it is to graph. So we'll use my Wii video skills and merge the two videos together. Knock on wood. All right, see you in a couple seconds. Let Desmos work some of its magic. I am going to put our constraint formulas in here. If I remember correctly, we had 5 wheat, so I'm going to put in X instead of W, plus 2R, I'm going to put in a Y, and that was less than or equal to 180, and it was 3 wheat plus 3 rye is less than or equal to 135. We also had the X had to be greater than or equal to 0, and that Y had to be greater than or equal to 0. Now both of those are representing the wheat and the rye. And I'm going to change this to the same color. Sometimes that's a little easier in order to see the feasible region. Now this is kind of a mess as we look at this. So obviously we have the constraint that X and Y are greater than 0. We have our 2 lines that we graphed before, right? We can see the intercepts. We had those at that point before, we had that point before, right? So there's a feasible region. And sometimes that's a little hard to actually see. So I'm going to show you a little trick. What I like to do, instead of putting the constraints in, like I said, I actually do the opposite. So where it said less than, I'm actually going to put in greater than, and where it said greater than or equal to, I'm going to put in less than or equal to. What I really like about this is then the feasible region shows up in white, and you don't have to worry about all that double overlapping. And that's what we got on our graph, and obviously on Desmos, we can just click on those vertices, and those are the same vertices we had before. Oh my gosh, I lost my 0.45. And those are the points at which we can maximize our profit in this case. On the guided notes, I showed you the long by hand way to do this. Let me show you how Desmos can help us out with this. So I'm going to make a table, and I'm going to put in our values where our vertices were at. So we have 0, 0, we have 0, 45, notice how the little box would come in, love it. Then we had an x-intercept at 36, 0, and then the last one we had was at 30, 15. So those are our feasible region, vertices of the feasible region, sorry. Now, it's hard to see, but there is a little line right here, and if you click to the right of that, we are going to type our maximizing equation. So we are going to make $40 per wheat bread and $30 per batch of rye bread. Now, in this case, X1 is representing my wheat bread, and Y1 is representing my rye bread. My rye bread. I did not mean that pun. Now, here's the weird part. We have to put this in as X sub 1. So you just click, type X, and then hit 1, and it automatically makes it a subscript. Then we're going to put in 30 times Y1. And you notice how it just filled in all of our blanks there for me? So I tab out of this. I only need a new one. I'm just going to tab to a new line. Kind of see that and scroll around a little better. So we got the same numbers. No wheat and no rye, no profit. No wheat and 45 batches of rye, we make $1,350. $1,440 for just 36 batches of wheat. And then our maximum is going to occur at 3 batches of wheat and 15 batches of rye. Isn't it so nice that somebody else programmed this for us? Love, love, love Desmos. Always will. They just keep improving. All right. So you know you're going to get your practice at this. Honestly, the hardest part is coming up with the constraints. When you have that, we'll let Desmos help us out.